Hello, everyone. So we're going to go over 9.2 patterns in a table of values today. And we're going to start by talking about a linear relation in more detail. So we're going to start by describing what a linear relation is. So a linear relation is a pattern made up by a set of points that form a straight line. So they don't need to be connected together. Um, they can actually just be individual points like we have here, 1, 2, 3, 4, the 4 points, and that will still be considered a linear relation. So a couple of definition. Number one, linear, as you may know, it means a straight line. Now, over the course of your high school mathematics career, you will see nonlinear relation. So, for example, sinusoidal, which would look like a wave. Oh, that's not very well drawn. So, wave, that's better. Or a quadratic one, which will decrease and then increase up the other side. But for now, we're going to focus on just linear relation. So, that will be the ones in a straight line. So, relation. Relation is just a relationship between, well, for us, two sets of numbers. You can be more than two sets of numbers, of course, but for right now, just the two sets of numbers. All right. Now, there's a specific kind of relation known as function, but that is not something that you need to worry about too much until Math 10. But it is a word that you might hear people say sometimes. So, just so you're aware, a function is just a specific type of relation. It has to fit certain criteria. You can think of it as how all squares are rectangles, but not all rectangles are squares. So all functions are relations, but not all relations are functions. Okay. So we're gonna look at linear relation in a few different ways, primarily through a graph or a table of values. These are things that we looked at in the previous section already, but also as a as described in words, and then also finally um, with a equation of some sort. So you can see here we have mass versus cost. We don't know what the items are. We just know that 100 grams of this item costs 200 cents. Oh, I said dollars the entire time while I was teaching today, but that's okay. So it is, and then 200 grams is 400 cents, so $4, and so forth. So M and C are known as variables because they represent unknown quantities, so they can change. Variable. All right. So what is the difference for consecutive M values and what about consecutive C values? You can see that as M increases by 100, C increases by 200. So you can just write that down. M increases by 100. You can include the unit, grams. And then C increases by, oops, sorry, 200 cents. Okay, so now you can describe this relationship in words, um, and we're going to write it in a very specific way. The reason for doing this is to better prepare ourselves to change this into an equation or or a mathematical expression. So I'm going to write this as C is the same as 2 times M. Okay, so now what we can do is look at each part of the statement. There are, oops, there are basically 4 parts of interest. Okay, let's go ahead and look at them individually. C is the same as 2 times, and then m. So the letter C, of course, stays the same, is the same as in mathematics just means equals. 2 times would just be 2 times multiply, and then m. So you can see that each part of our statement corresponds to a part in our mathematical expression or equation in this case. C is the same as or equals to 2 times and then m. So now you can also treat the 2, of course, as just a coefficient in front of the letter, oh sorry, the variable m. So C equals 2m is another way of writing this. It's a little bit cleaner, a little bit more concise. And again, this right here, coefficient. So a coefficient is a number that you place in front of a variable. It means to multiply by that coefficient. All right, so now sometimes you can be a little bit more concise with your words. So you can express what we just said is cost. Notice I didn't use the variable C, I used the actual word cost is twice the mass. So no variables here, just words. And as an expression, we already wrote that down. C is equal to 2m. Now for this specific example, we are only given 4 points, so we can write them as ordered pairs, not as an ordered pair, but multiples. So the ordered pairs we had were 0, 0, 100 grams for 200 cents, and then, 200, 400, and finally 300 and 600. Okay, so moving right along, we'll also have instances where we don't have a linear relation. So I'll make it pretty obvious that it is not in the example. So let's look at these two table of values together. So first variable in each example, there's x here and m. So if you look at the table values very carefully, this plus 2, plus 2, and plus 2 for the x's, and then plus 1, plus 1, plus 1 for the m's. So in other words, you can just write this as x goes up by 2's, and then m goes up by 1's. All right, so the second variable in each table of values, they are y and n respectively. So for the y variable, you can see is increasing by 4. 3 plus 4 is 7. 7 plus 4 is 11. 11 plus 4 is 15. And then for the n variable, you have plus 3, and then suddenly plus 1. So that's a bit problematic because, well, there's no common difference. So the pattern doesn't continue. So y, we'll say that the common difference, and that is the number that you add or subtract every time. So the common difference is 4. And then the n, the common difference is, well, 3 until it wasn't 3 anymore. Except for the last part. All right. So if this example table 2 were to follow the pattern, this really would have given you a 10. but it doesn't. So we know that table 2 is nonlinear. Okay. So, but to further demonstrate that, we're going to look at a graph, or actually we're going to look at two graphs. Now for graphing, it is important to make sure that you label your axes very well. So in this case, the x and y values, the x value goes up to 8, and you can 4 spaces here, so it's very convenient. We just have 2, 4, 6, and 8. The y values goes up to 15 if you look at the table. So it goes up to 15. But we have 1, 2, 3, 4, 5, 6 spaces, so that doesn't quite divide evenly. But in order to make it best fit, we can just have the y-axis increase by 3 at a time. So 0, 3, 6, 9, 12, 15, and then 18. So we maximize the amount of space that we take up, but at the same time, we maintain a consistent pattern. So using whole numbers. So we're going to go ahead and plot our points. The first point was 2, 3. You don't have to label the points every time, but I think it's better visually if I did for this case. Next up, we have 4, 7. So every value here goes up by 3. So 6, 7, 8, 9. So it goes up by 1/3. So this would be 4, 7. Followed by 6 and then 11. So 2/3 the way up from 9. And finally, the last point is 8, 15. So that would be nicely labeled. Okay, so if you were to go ahead and draw a straight line through the 4 points, and like this, oops, that's way off. You can adjust. So you can see that we can draw a straight line through all 4 points pretty easily. Okay. Oops, there we go. So the graph on the left will definitely be linear. This is from table 1. The graph on the right, the x values, the m values were given were 1, 2, 3, and 4. So here we have 1, 2, 3, and 4. And then the n values, it goes up to 8, but because we have 5 spaces, we're actually just going to go up by 2 at a time. 2, 4, 6, 8, and 10. Again, we maximize the amount of space that we take out, but maintain a constant difference going from 0, 2, 4, 6, 8, 10. So 2 at a time. And from there, we're going to draw our points in. So the first point is 1, 1. The second point was 2, 4. And then 3, 7. Oh, this is 2, 4. And then finally ends up at 4, 8. So even if I didn't draw a line through the 4 points, you can see pretty clearly that this doesn't form a straight line, right? It doesn't go through the last point correctly. So we can say that this example is nonlinear. Or not linear. Okay. So from there, it says how do you compare these two? Again, table 2 is a key here. It has no common difference. And so therefore is not linear. So if you are looking to see if a table of values is representative of a linear relation, you're looking at a common difference somewhere. This is what you're looking for. And again, that's our conclusion here. Common difference would lead, for the variables, would lead to a linear relation. Okay. So sometimes it is difficult to find how the variables are related because it's not going to always increase by ones or increase by twos. So we need to look at the table of values and sometimes look at the in between values to see if it actually forms a straight line. Okay. But for now, we're going to keep things pretty straightforward. Example 2. So to rent a photo booth at an event costs $100 for the first hour and then $20 for each additional hour. So we're going to make a table of values, hours, and then of course we have cost. So 1 hour is $100. 2 hours is $120 because each additional hour is $20 more. So we can have 1, 2, 3, 4, and 5. And every hour, the cost just increased by 20. So 140, 160, and then 180. All right, draw a graph from the table of values. So first thing you want to do, of course, is draw some axes if you're just given a blank grid. Oops. Try that again. There we go. So that's my y-axis. It's my x-axis. Now, of course, you might want to not always draw your axes with the origin at the center of the grid because you want to, um, it depends on how many positive or negative values that you have. So in this case, all our numbers are positive. So we're going to have as much space as we need on quadrant 1 or the top right corner of the graph. Okay, so in this case, 0 of course goes in the origin, and then we have 5 hours, so maybe 1, 2, 3, 4, and 5. This is for hours. And then cost, so if you look at the cost part, there is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 spaces. So each space would just be $20, 20, 40, 60, 80, 100, 120, 140, 160, 180. So we're not going to draw the 200 because we don't need it. So now what we're going to do is plot the points that we have on our table of values. 1 hour is $100, 2 hours 120, 3 hours 140, 4 hours 160, and 5 hours $180. And you can clearly see that this is going to make a straight line. So I'm just going to go ahead and draw that in. This color. There we go. So what you'll notice is that this graph, it intersects the y-axis here. So I'm going to go ahead and label that point. This right here is not part of the graph, but it is going to be very informative for us. Oops. Because what we can do is we can use it to write our equation for relating hours and cost together. Now, as an aside, probably should have mentioned this before, notice that I put the C, which is cost, on the y-axis and the hours, which is h, on the x-axis. And that is simply because the cost depends on h. So from the previous class, you will know that the y variable, which goes on the vertical axis, the y-axis, um, is the dependent variable, and then the independent variable or the x variable is the horizontal one. So c depends on h, so therefore, oops, c is on the y-axis, and h is on the x-axis. All right. So imagine if you rented the photo booth for 0 hours, it would be the base cost is $80. We're going to write that as an equation now then, and that is to say cost is equal to $20 multiplied by the number of hours plus the base cost of $80. So if we were to label this, 20 is the hourly rate and 80 is the base cost for the whole operation. Now, but the number 80 doesn't actually is not actually in the question anywhere, so you might want to write the equation in a different way that addresses that. So another way to write this equation is to say that the cost is still equal to 100. So that is, of course, cost for 1 hour plus $20. This is the hourly, multiplied by h minus 1. And that is the number of hours beyond the first, right? So if you substitute in 2 for h, 2 minus 1 is 1. And if you rent the photo booth for 2 hours, you're renting it for 1 hour beyond the first. And that's when the $20 hourly rate kicks in. Okay. So that is we already did question C. I think it's better if we just um, kind of put everything together. And finally, letter D, what is the cost if you rent it for 12 hours? So we simply use our equation. C is equal to $20 per hour multiplied by 12 hours plus the base cost of $80. 20 times 12 is 240 plus 80 is $320. Oh, include my units, 320. And that's, of course, for letter D. And that's it. So that concludes how we can look for tables look at table of values and determine some patterns. Then we can describe those patterns using graphs, using um, words, or using expressions. And that's it for today. Thank you for listening.